Okay, let me scoot this back. Ignore how messy my office slash crafts room is because right now it's a total wreck. Okay, so the different types of joints. You need to be looking at your PowerPoint right now because what I'm going to be doing with my hands is going to pertain to what you're seeing on your PowerPoint. Um, Again, the editing thing is going to be kind of a pain, and I apologize for that, but I have to be able to see what I'm talking about too and see myself on the camera. Hopefully, they can be similar to each other. We'll see. We'll see how that works. Nope, that didn't work. I hope I'm not bringing you nightmares by you seeing my face. Sorry about that. Okay, so plane and gliding joints. You have two flat surfaces that are opposing each other, okay? There's a slight amount of glide to it. So remember I told you we have the X plane, the Y plane, and then the Z plane is coming straight at your face, right? Well, these move either on the Y plane, on the X plane, or on the Z plane, but it's just one of those planes. So they're considered uniaxial because they only move on one of those planes. Now, the saddle joint is a bit different. You have basically two saddle shaped pieces. So here's a saddle that a monito can sit in. So you've got two of these that come together. And when they move like this or they move like this. So since they move on two planes, they're considered biaxial. Your thumb is a really good example of this. The thing about your thumb is you move it this way, you move it this way. Now I know everybody's going, but I can do this with my thumb. If you really pay attention to what you're doing though, when you get to the corners, you'll feel it grind because basically what you're doing is you're hitting on the ends of the saddle. Dun, da, da. Let's see. Hang on a second. All right. So, next slide, the hinge joint. Think about a door hinge for a second. You've got, I love the way this sounds, the convex cylinder of one fitting into the concave portion of another. So you've got kind of a sticky inny part with a sticky outy part fitting in so that it moves. Your elbow is a really good example of this because it does this. The thing is, this elbow right here only goes in one plane. Now, I know you're probably thinking, well, I can move my arm like this. That's actually happening up here. It's not happening at your elbow. Your elbow, like a door, can only open and close, and that's it. Now, a pivot joint, the fourth joint I'm going to talk about, is actually relatively cylindrical. So you've got kind of a bone over here, you've got a piece of ligament here, and you've got a bone sitting in between that pivots around, that goes around. A good example of that, if you look at your PowerPoint, you can see the round head of the radius up against the side of the ulna, and this is one of the things that allows us to do this motion with our hand because of that pivot that's actually happening over here. And again, as far as motion, this is uniaxial because you're just pivoting in one spot. Sorry, guys. All right, the last two. We've got the ball and socket joint. The ball end of one bone fits into the socket of an adjacent bone. Now, because you've got a sphere on the end of one bone, your hip being a really good example, your shoulder being a really good example, you've got a lot of different types of motion there. You have the ability to take your arm up or down, back, forward, even in a circular motion. So we consider this to be a multi-axial joint because we've got so many different types of movement that we can do with it. Now, ellipsoid, ellipse, if you think back to your, I guess, grade school days, an ellipse was an oval. Instead of being a perfect circle, now we have an oval. So if you look at the picture, you can see that you've got an oval shaped ball fitting into an oval shaped socket. Now, the thing about this type of joint is it's not a perfect sphere like what you have in your shoulder or what you have in your hip. It's actually going to give you that biaxial motion that you see. Let me see here. Biaxial motion that you see in ovals, because when you try and go into the corners, it's going to hit on those corners and it's not going to be as mobile as a sphere would be, like you see in the ball and socket. Because of that, we say it's biaxial. Your occipital condyles on the underside of your skull fitting into the top of atlas, the vertebra that holds your skull up, actually is a type of ellipsoid joint. Your knee, where your fibula actually fits into the top of your tibia, is two ovals. So your knee has a lot more motion than a hinge joint like your elbow, but it still is kind of limited in what it can do. Okay, wanted you to be able to see me for that part. I hope this works. If it doesn't, let me know.